Welcome to another PLC Professor presentation. This presentation, entitled RSLinx Drivers, is a replacement for the current video in the Basics series titled RSLinx Driver Configuration. It's part of the Basics series. This presentation is also going to be to basic level. For more information on what RSLinx is and a more detailed discussion, if you like, you can watch the RSLinx videos in the playlist titled PLC Communications. And as I mentioned, this presentation replaces the current video that's titled Basics01 RSLinx Configuration. The former and the new videos are in support of the Complete PLC Learn series. The Complete PLC Learn series was developed around the inexpensive Micrologix 1000. The former video and the new, the replacement, are in support of the Complete PLC Learn series Lab Project Manual, which is available at the PLC Professor's web bookshop. If you go to www.plcprofessor.com and click on the bookshop tab, you can find the manuals and the disc sets, as well as a hardware trainer if you don't want to build your own. The Complete PLC Learn series was developed around the inexpensive Micrologix 1000 10-point I/O controller. We picked that because Rockwell provides pro gratis software, RSLogix MicroStarter Lite and RSLinx Classic Lite from Rockwell Automation. Because the free version of software supports both the Micrologix 1000 and the Micrologix 1100, we will use both of these in this presentation, but we will start out with the 1000 and then we'll go to the 1100. The Micrologix 1100 also affords us the opportunity to configure the Ethernet devices driver and demonstrate using the DF1 driver to assist in setting up the IP address in the controller. If you are using RSLogix Emulate 500, there is a video in the Training Support playlist, TS02 RSLogix 500 Simulator, that covers all the aspects of that endeavor. Configuring an RSLinx driver, whether it's for a PLC5, a SLC 500, a Micrologix, a ControlLogix, a CompactLogix, FlexLogix, the process is identical. An RSLinx DF1 driver is an RSLinx DF1 driver. Ethernet devices driver, because remember that these drivers drive a port on your personal computer, and that port is connected by cable to a like port on the controller itself. Before we get too carried away with configuring a driver, let's discuss the relationship between an RSLinx driver, the PC, and the PLC. So we all start out with a PLC. We go down to the corner PLC store and we buy a nice pretty PLC. And we want to use that PLC to control something. In order to communicate with the PLC, in order to speak to it in its language, on our PC we need RSLogix. Some form of it, RSLogix 500 Pro, RSLogix 500 Standard, RSLogix MicroStarter, or RSLogix MicroStarter Lite. But we need RSLogix. We also need a COM port on the PLC. In this case, the PLC that we use most often in the Complete PLC Learn series is the Micrologix 1000, and it has one COM port, an RS-232 port. The Micrologix 1100 has two ports, which gives it a major advantage. The Micrologix 1100 not only has two COM ports, RS-232, which can be configured for DF1 or DH45, but it also has an Ethernet port. And by Ethernet, I mean TCP/IP Ethernet, not Ethernet IP or the industrial protocol, which is supported by ODVA. So this is just a standard Ethernet TCP/IP port. We have a PLC with two COM ports. We have a PC that also has two COM ports. In this case, I show Ethernet and USB because most laptops. Most people use laptops these days instead of desktops to communicate with a PLC because of the mobility, the portability. Any laptop that has been manufactured in the last 3 or 4 years probably does not have an RS-232 port, but it does have a USB port. And if you go to the PLCprofessor.com website, go to useful links, you can find a link to purchase a USB adapter and cable, PMO2 type cable, to connect between the USB connector on your PC and the RS-232 connector on the PLC. Now the RS-232 connector on the PLC, it is not a 9-pin sub-D shell. It is a round DIN connector. So you do have to have a semi-special cable. But be advised, you can find both the USB adapter and the cable available on eBay and other locations for under $30. I find them a combination for $15 to $20. Don't hesitate to buy things on eBay, but you have to pay closer attention to what you're doing. So if you actually type in PM02 cable, when you search on eBay, you will find not only the original Allen Bradley cables for sale, new and used, but you will find substitute cables that are quite a bit less expensive. To that USB port, let's tack on an RS-232 adapter. So now we have 2 ports on the PC and 2 ports on the PLC. And of course we need to connect them with cables. Now I show connecting both cables and connecting both ports on both devices. That's not necessary. You only need 1 port and cable between the 2. But since we're going to use a Micrologix 1100 and we're going to configure the drivers for both RS-232 and Ethernet, I'm showing both in this diagram. But keep in mind, you could use just the RS-232 or you could use just the Ethernet. You will not use both in normal practice. There would be no reason to. We have RSLogix that we want to use to write a program and then download it to the PLC. We want to be able to go online with the PLC and monitor the data table in the PLC. Remember that when you go online, you are viewing the offline project on your computer, but the ladder logic is animated by the data from the database in the PLC. You're not looking at ladder logic in the PLC. There is no ladder logic in the PLC. That's machine code. Ladder logic is something that we use to write a program with. When you download it, it's compiled into machine language and sent down to the PLC. When you create your RSLogix project, one of the steps or one of the efforts is channel configuration. In other words, you're going to write a program in RSLogix that you're going to download into the PLC. In order for the PLC to know what configuration you want for its communication channels, you write that configuration in RSLogix and then you download it to the PLC. Since we have a Micrologix 1100, we have channel 0 and channel 1. Channel 0 is RS-232, channel 1 is Ethernet. Of primary interest on channel 0, a DF1 driver, is the baud rate. Now there's more to it than just the baud rate, but I'd put baud rate up there because that seems to be the major barrier for getting the driver set up correctly. And then for channel 1 Ethernet, it's the IP address. And of course you know that the IP address is not the Ethernet address. The Ethernet address is the MAC ID, a 48-bit set of characters that uniquely identifies every single Ethernet port in the world. So the Ethernet address you don't use. You can view it when you are online with a PLC and write it down if you like. Channel 0, we talk about baud rate, DF1 baud rate, and channel 1 Ethernet, we talk about the IP address. So when you first write your program, you do a channel configuration and you either set up the DF1 port or the Ethernet port. You can set up both if you want, because we're going to do both, because I don't know which one you want to use in your project. We have a channel configuration that is resident in RAM in the RSLinx application. If you close RSLinx and save it, then that channel configuration is still resident, but it's on your hard drive. Now the PLC itself also has a configuration for its RS-232 port and its Ethernet port. So when it arrives from the factory, it is configured. It's not necessarily configured the way you want it to be configured. Specifically the Ethernet port, it is actually set up for boot P, which is very similar to DHCP. If you're not familiar with DHCP, then you need to set some time aside to study Ethernet and Ethernet communications. But basically, in a nutshell, boot P and DHCP both require a server to temporarily lease an IP address to the controller. You want a permanent IP address. You want a fixed one. I shouldn't say permanent, but you want a fixed IP address. You don't want to turn on the PLC, have it send out a message, a broadcast from its Ethernet port with its MAC ID sending out a message saying, hey, here I am, give me an IP address. You want it to have a fixed IP. So now we have channel configuration in two locations. We have the offline project, and it has a baud rate for DF1 and an IP address for Ethernet. And that's resident either in the RAM of your PC or on the hard drive. And then the controller itself comes from the factory with configuration for those two channels. Now, in order to communicate between RSLinx and the PLC, we need RSLinx. RSLinx is a driver manager. You can configure almost an unlimited number of drivers in RSLinx. The RSLinx drivers for these two ports, RS-232 and Ethernet, are DF1 and Ethernet devices. And the driver itself has configuration for both of those drivers. So I showed as one box here, but really it's two separate drivers. There's a DF1 RS-232 driver and there's an Ethernet driver. But I showed them in a similar box form to make my point. So when you look at this diagram, at any given time after you've done some project development, done some downloads, how many different locations are there for a baud rate for channel 0 DF1 driver? How many locations are there for an IP address associated with the Ethernet port? 3. In the project, in the drivers themselves, and then also in the RAM of the PLC. We kind of have a saying, you always need to keep in mind who's on first, who's on second, who's on third, and if you do so, you'll hit home runs every time using RSLinx, RSLinx, and a PLC. Let's continue by opening up RSLinx. The first thing you might notice is that it says RSLinx Classic Gateway. This is a more expensive version of RSLinx. This is not the free version. The free version is RSLinx Lite. I just happen to have this version on this laptop because I use this laptop for a lot of other purposes. It also says RSWho-1. If you look over in the upper right-hand corner, you see a red X, that's for RSLinx. Then you see another X, that's for RSWho. If I close that, you see I have nothing in my workspace here. RSWho is not RSLinx. RSWho is a application that allows you to view or browse a driver. So I don't have any drivers right now. It just shows my workstation. So I'm going to close RSWho. And by the way, you can open up as many RSWhos as you want. RSWho1, RSWho2, RSWho3, etc. So you can browse as many drivers as you want, or I should say as many as you have configured. A little explanation of the menus is probably in order here. File we're not going to go over these features in the basic level. We'll save Open Project for the advanced level. There's also Edit. We are not going to discuss Dynamic Data Exchange or Object Link Embedding for process control. That'll be in a more advanced presentation. What we would like to do is look at communications, because that is what we're talking about. Communications between the PC and the PLC. So if I drop down here, you see several choices. None of these are we really going to talk about other than RSWho. The two primary buttons, RSWho, so this RSWho opens up RSWho, and this RSWho opens up RSWho. Normally in Windows you can find at least two different ways to do the same thing. And then of course configure drivers. I call it the double-headed snake. And that's what we want to do first. By the way, you can find help that is in this application. In other words, basic RSLinx help. I'll drag it over from the other screen so you can see it. So you can find a lot of information in the RSLinx Classic Online Help just by clicking on the Help button. And then you can also go to a quick start. And there is also about RSLinx Classic. And you can see here that it's got a phone number to call for technical support. Let's go to Configure Drivers. After all, that's what we're interested in. So we click on Configure Drivers. And remember, we're going to do the RS-232 port first. When you first look at this, it looks like you really can't do much but either close or ask for help. Everything else is grayed out. However, this drop-down list is not grayed out. So we click on that list and we pick RS-232 DF1 devices. A device is a piece of electronics. So you notice most of these say devices. We pick our RS-231 DF1 devices and we say Add New. Notice that this is now active. It's not grayed out because you have something in this drop-down list picked. So we click on Add New, and it gives you an opportunity to change the name. Now personally, I don't change the names because somebody's not going to like that name. So I just leave it AB_DF1-1. Now if you configure a second DF1 driver, it'll be DF1-2. You can leave this as is, or you can type in a name. We'll call ours Monkey Shines, just to prove that it really doesn't matter what you name it. I remember years ago when I first saw this pop up, I looked at all of those details and thought, oh my, where am I going to find all this information? Then I saw the magic button down here, Auto Configure. Now in the old days, 10 years ago, laptops had RS-232 ports on them, 9-pin sub-D shells. When they did, they were almost exclusively configured as COM1. Doing an auto configure, once you had this box open, you would just click on auto configure. You didn't have to change anything. I'm going to do that so you can see what happens. Unable to open the specified COM port for configuration testing. That is your operating system telling you through your I/O structure that COM1 is not available. Now I happen to know that the USB adapter that I have is connected to COM4. So I'm going to select COM4. Now if you don't know how to determine what COM port, software COM port, is connected to your hardware COM port, then go to Computer in your menu, right click, Manage, and when that pop-up comes up, then click on Manage Devices, and then when the list comes up, go down to LPT1 COM ports, open it up, and you will see your USB adapter, and in parentheses you'll see a COM port. I know it's COM4. Now I can hit Auto Configure. Now watch what happens in this little window right here. What you're going to see is many iterations of a broadcast or a message that my laptop is going to send out through COM4. It's going to send out the configuration you see right in front of you. Devices, PLC channel 0, baud rate 19.2, station number, error checking. It's going to send out a message. If it doesn't hear anything back, and it may try a higher baud rate to begin with than 19.2, it's going to send out a message. If it doesn't hear anything back within a couple milliseconds, it will reconfigure the message with one of the details changed and send it out again. And it will keep doing that over and over again, each time changing a detail until it hears back. When it does hear back, then it knows that it's configured in a configuration that matches that of the target on the other end of the COM port. Because remember that COM4 is we'll call it a software port, but it's assigned to a port, an actual USB port on your computer, and you have a cable going from that USB port that has an RS-232 adapter built into it, or it's separate and you plug them in together, and it goes to the RS-232 port on the PLC. Let all that disappear in your mind, and basically COM4 is your PLC, assuming that you have the right cable connected. So when I hit auto configure, watch what happens in the box here. See, testing, different. Oh, auto configuration successful. Now, in the early days, when I saw this, I jumped out of my chair and did a jig, did a little dance around the workbench, and acted like I was pretty hot stuff. Well, once you've done this a couple hundred times, the blush goes off the rose, so to speak. In other words, it's not as sweet as it used to be. If you've ever had trouble communicating with a PLC or getting connected, then you can really appreciate auto configure and auto configuration successful. If you look up at the details now, COM4, SLIC channel 0, micro panel view, baud rate 9600. Notice it said 19.2, now it says 9600. So what you're looking at right now is a mirror image of channel 0 configuration from the PLC. We're plugged into the PLC right now. Maybe I didn't mention that, but I do have a cable going from a USB port on my laptop through a USB 232 adapter into a PMO2 cable plugged into a Micrologix 1000. So say OK. Now you can see that it's running. I'll close this and I'll go to RSWho, and there's our driver. We're workstation PLC professor, and then we have a driver. And it shows this driver sees both ends. You know, you have a cable that goes from the PLC to the PC. And one end of the cable is, we'll call it node 0 if you like, workstation DF1 COM4. And then the other end of the cable is a Micrologix 1000 that currently has a name MyPLC. So that really concludes configuring an RSLinx driver, a DF1 RS-232 driver, between your laptop and a Micrologix 1000. Just for grins, I'm going to leave that open, but I'm no longer browsing. See, not browsing right there. If I click here, then it's browsing. Anytime you want to do anything with this RSWho offline, or you want to go change something, click on your workstation. Click up here so it's not browsing, because you can't change this if it. Let's close this. This is enough to get you working with your Micrologix 1000. You don't need to go any further with RSLinx than what you see right here. We're going to go back, we're going to delete all that and do it all over very quickly. So I'm going to go back to drivers, delete all the drivers, close. You open RSLinx, go to the driver, configure drivers button, pick RS-232 DF1 devices, add new, leave the name the same, change the COM port to match what your USB is assigned, hit auto configure, and you're done. Click OK, close. You can even close RSLinx if you want and go offline. But RSLinx is now configured, so when you create your project and you go to download, it will find this driver. The driver will find the PLC that you configured it for, and you're in business. Now I've hooked up That PMO2 cable, I've removed it from the Micrologix 1000 and I have plugged it into the Micrologix 1100. So I'm going to go to the driver, and this driver is probably working fine, but I'm going to delete it because I want to start from scratch with the Micrologix 1100. So we select RS232 DF1 devices, add new, OK. It's still plugged into COM4 on the laptop, but it's plugged into a different PLC. Hit auto configure, and immediately it says successful. Now it just so happens that the baud rate for the 1100 was set at 19,200, which is different than what the Micrologix 1000 was. You see the procedure for configuring the driver to go to a Micrologix 1000 or a Micrologix 1100 is 100% identical. Everything you see up there other than the baud rate. And we could change the baud rate in the 1100 and do this over just so it configures at 9600. But that's unnecessary. So let's accept that and close this. Go to RSWho, and there's your Micrologix 1100. Okay, I'm going to stop that from browsing. I'm going to go back to available driver types to configure the Ethernet driver. Drop down the list, Ethernet devices, add new. The problem here is this: we don't have an IP address to type in. I'm going to stop here. This is where everybody kind of gets hung up. I'm going to stop here and show you how to find that IP address. I'm going to cancel, close, and I'm going to open up RSLogix 500 or RSLogix Micro Starter, Micro Starter Lite, whatever you're using. I'm going to go to Comms, System Comms. I'm going to pick that 1100 and I'm going to say upload. We don't have an offline project that matches what is or is not or might be in that 1100. Because we're doing a specific procedure to look at the IP address, we really don't care what's in there, but you always want to upload before you start making changes and then save what you upload. So we're going to create a new file, and so now it's uploading, but remember there was no offline project to save the online data table to, because that's really all you're saving is configuration and data table. Do you want to go online? Yes. And you can see there was some kind of program in there. We're online in the run mode. Now, remember we were interested in configuring Ethernet drivers. So we go to channel configuration, double click, or you can hit the expand and then click on it. So you see you have general, you have channel 0, which is RS232, and you have channel 1, which is Ethernet. Now, this takes a little discussion. Notice that there's a hardware address. That is your MAC ID. That's a 48-bit displayed as octets, 8-bit patterns. So there's 1, 2, 3, 4, 5, 6 8-bit patterns. 6 times 8 is 48. Notice that the IP address, subnet mask, and everything else is all grayed out. The reason they're grayed out is because boot P enable is checked. If you leave this checked, then every time you turn off the controller, you lose the IP address. When you turn it back on, the controller sends out a broadcast on Ethernet. Hey, here I am, 000F73001186, the MAC ID. It sends it out. If there's a server out there that recognizes that MAC address and is assigned an IP address, it will then send a message back and say, hey, you're 192.168.35. That's your IP address, subnet mask 255.255.00. We don't want to do that. We want a fixed IP address. So we uncheck boot P enable. Notice this is all enabled now. So I have a penchant for a certain IP address. That's because it's real easy to type in and easy to remember. I like to say 100, 100, 100, 100, 100. Or after my wife has corrected me, 100, 100, 100, 100. Normally, I assign my personal computer to 100, 100, 199. They cannot both have the same IP address. And then I put in a subnet mask of 255, 255, sometimes 255 and then 0. It depends on what I'm up to, whether I do 255, 255, 00, or 255, 255, 255, 0. Now the subnet mask, and we're not lecturing on Ethernet. You need to set aside and study Ethernet on your own. But each of these is called an octet. So 255 is 8 bits, all ones. So 8 bits is 0 through 255. So if you looked at the subnet mask as a bit pattern, you would see that there are 24 bits on the left, and then on the right, the 0 is 0, 0, 0, 0, 0, 0, 0, 0. It's an all 8-bit 0 pattern. So the octet on the right is actually your network. So this means you have 256 nodes in your network. The subnet mask defines what is actually your network address and what is your subnet. That's as far as we're going to go right there. Okay, so you put in an IP address, and by the way, the IP address has to be in the same network as your laptop. So your laptop would have to have an IP address of 100, 100, 100, and then something. So the fourth octet in the IP address for your laptop and here for the controller have to be different. Now they can be anything basically 1 through 254. We don't use 0 and 255 for our IP addresses. I picked to make the processor 100, 100, 100, 100. And then the laptop I made 100, 100, 100, 99. But I could have made it anything other than 100. So you can't have duplicate node addresses. So to put this in a simple summary, you opened up channel 1, you unchecked boot P enable, you typed in an IP address, the first 3 numbers or octets of which are identical to those of your laptop's Ethernet IP address. And then the fourth octet, the controller we made 100 and the laptop is 99. And then of course for subnet mask we put in 255, 255, 255, 0. And that's all there is to it. Apply. I'm going to hit OK. Now it's saying that loss of communications on other channel 1 will occur. That's because we just changed the setup for the Ethernet channel. Now we're using RS-232, so we're not worried. So I'm going to say apply. Then I'm going to go back into channel configuration, go to channel 1. In the old days, if you didn't hit apply, then when you came back, boot P enable was still unchecked. This is the most important step, and that is to make sure that boot P enable is not checked. Then hit apply and OK. Now you have your Ethernet port on this controller with a known IP address. At this point, if you want to communicate with it, the Ethernet address on your laptop, remember, has to be 100, 100, 100, and something other than 100, with a subnet mask of 255, 255, 255. Close this. Now we're going to go back and configure our Ethernet devices. So maybe I did that too fast. We'll close this too. Start from configure drivers. We want Ethernet devices. Now there's also an Ethernet IP driver. That's a more advanced subject and not for this particular controller. So Ethernet devices, Add new, leave the default name. Now, you actually have to map in, if you want to call it that, all the IP addresses you expect the driver to find. So I'm going to type one in for the controller, which is really all you need. But I'm also going to type in the one for my laptop just because I like to see it. $100, $100, $199. You got to have the decimal points in there. Add new. And there's our controller. So that's our laptop and that's our controller. You don't need the 99. Okay, so I'm going to hit apply. Okay. Close. RSWho. And there's our Micrologix 1000. We'll kind of close this up a little bit. We'll open up another RSWho. And we'll expand our, and there we have two drivers configured to the same controller. So this Micrologix 1100 L16BWA and this one are exactly the same controller. This one's RS232 and this one's Ethernet. Now, why would we do this? We wouldn't. However, you definitely can use both ports on the PLC. One to an HMI, a screen, a monitor, a operator interface terminal, and the other to plug into your laptop. The nice thing about the 1100 is that it supports Ethernet. And Ethernet is very easy to deal with if you know what the Ethernet address is, or the IP address in the controller. And for the 1100, it's very simply a matter, as we demonstrated, you configure an RSLinx 232 driver, go into the controller, look to see what the configuration is for the Ethernet port in the controller, uncheck bootp if it's checked, type in an IP address, make it fixed, and then go to your laptop and change the Ethernet port on your laptop to be in the same subnetwork, and you're all set. The nice thing about Ethernet is the cabling, the routers, the switches, and the hubs. It's just a much easier network to deal with than DH45. Now, I realize this driver says DF1, DH45. It is really DF1. We picked DF1, not DH485. That concludes our basic level presentation on configuring RSLinx drivers. Thank you for watching.